you don't have to work alone. It's a big mistake to work alone. I got a lot of money. I got something like 1 million euros, and I got a lot of money, but I have a lot of enemies also. So you have two possibilities. Either you fight and people you think are crazy, or you take the things with humor. New York is more important than Princeton. I'm trying to pull yourselves. I try to, I'm not sure I can, but I try.
So, welcome to Math-Life Balance. Today,
Yes.
our guest is Max Karoubi, Professor Emeritus at the University of Paris 7, working in K-theory and algebraic topology. Welcome, Max. It's a great pleasure to ask you about your rich experience in mathematics.
It's a great pleasure to talk to you also.
Thank you. So to start, tell us please about your background and what brought you into mathematics.
Yeah, it's a little bit complicated because I was not born in France. I was born in Tunisia, and my father was working the railway in Morocco. So my house was between Morocco and Tunisia. You see, until I was 20, more or less. You see. So what brought me to mathematics? It's a nice story, in fact, because my grandfather was a bookbinder in Tunis. And he asked me many times to help him to bind books. And when I was 12 or 13, I don't remember exactly, it occurs that I have to take care of mathematical books. And one of them was about holomorphic calculus. Of course, I didn't know anything about holomorphic calculus, but I was intrigued by formulas like exponential I pi equal -1. This was my first encounter with mathematics, if you want. And my second encounter was at school when I was following classes, undergraduate, very low level. I mean, for example, the professors asked us if a function was increasing, decreasing, and many times what he said is, well, you take f of x1 minus f of x2 over x1 minus x2. If it is positive, then the function is increasing, and when it is negative, it's decreasing. Okay? And after 100 exercises of this type, I got bored. I said, well, there should be a method to know if a function is increasing or decreasing without making all this calculus. And I have the intuition of derivative at that time. You see, I make some computation. I said, well, xn is like n xn minus 1 when you take this different and so on. But of course, I did not know what is a derivative. This was just an intuition. And after that, I think my uncle offered me a book about the story of mathematicians, the story written by Bell, I guess. And I read this book like an adventure book. You see, like people trying to understand what is a function, what is continuity, and so on. And I got fascinated by the story of mathematicians. And at that time, I didn't know if I would be a mathematician. In fact, my concern, because I was coming from a poor family, and my concern was to have a job after my studies. And among all jobs, I think I should be an engineer. So I wanted to study, to go to a school where I can be an engineer after my studies. Okay? So this was my concern. So I was not so much interested by mathematics, but my future, more or less. I got responsible for that. Okay. I was in Morocco, so the studies were not very high. See, so it was, I was, of course, the first at school, but there was no merit because all the other people were bad, see. So, so I was the first, but among people who are not so much interested by science or by studies. I got to Casablanca when I was 19, and in Casablanca there was a good how to say a good class to study mathematics, physics, and so on. And I said to my other students that I want to enter a polytechnical school. And the other students said to me, "You are crazy, this is a difficult school. what are you doing? Very few people are coming in political school. I got confused by these comments and said, maybe I'm not so good and maybe I shall be more modest and so on.
So how did you study and develop your interest in mathematics when people around you didn't care?
Well, in Casablanca, I tried to be the best with my Gillian's pack. See, we were two, and we were not really competing. We are good friends. Okay? But when I came to Paris, that was a different story. Then I realized that I was not the best. There were also very good people. So I became more modest, if you want, in Paris, yes, because the level was very high. The other students were, I mean, for example, they have read Bourbaki. I didn't know what was Bourbaki, see, when I came to Paris. I mean, Bourbaki was a strange figure. Okay? And when I entered École Normale Supérieure, I got a little bit discouraged because I said to myself, maybe Bourbaki is not I don't like Bourbaki, it's too abstract, it's not concrete and so on. So I got a little bit discouraged, you see. And I got so much discouraged that I got married. See?
You got what?
I got married.
Oh.
That's one way to escape the problems. Of course, when you are 20, 21, you think of something else than mathematics, okay? And the fact that I got married, in fact, gave me more confidence because I became more secure of myself, if you want. It's very important psychologically to have a good social environment, sentimental environment. You see, that's very important. I realized that this was important for me, you see. And not only I got married, but I got a child. And this was very important for me, yes. And this helped me to do mathematics, in fact. So it's very important for a mathematician to have, it's always what I say to my students, you have to work, but you have also to have a good environment, if you want, you see, social, but also sentimental. You have to be, secure of yourself. Because if you try to do mathematics, only mathematics all day, then you become crazy. See, you have to do something else. You have to think to something else also. You see, that's my feeling.
So you said you came to École Normale and you realized you were not the best anymore. Was it hard to accept that?
When you are studying until the age of 20, more or less, you pass exams. Okay, so I was very good in exams. I could solve a problem in very little time. See, for example, agrégation mathématique, I was second among 2,000 students. Okay, because I was very good in solving problems, but at high school, if you want, some problems, elementary problems. Okay, but you want to start research is a different story. See, you have to think of mathematics, not just of solving problems, but also asking problems, asking questions. You see, that's different. So the transition was very hard for me. And I got married because this transition was too hard, if you want. Yeah, that's a true story. I'm not cheating. It was very important for my equilibrium. See, to have an environment which was not just bachelor and trying to solve problems or asking questions. You have to do something else. Yeah.
I see. And then you did your PhD, right? And your advisors were Cartan and Grothendieck.
Yeah, that's a very strange story because when I was at École Normale, Cartan has a very poor idea of me because I got married. I was good in agrégation, but I was not able to do research really. See, so I went to see Cartan, and I asked Cartan, I want to do a thesis under his direction, and Cartan was lecturing about variational calculus, and Cartan told me, because you are interested in variational calculus, you should read Marston-Moore's book on calculus of variation is a large. It's a book that was written in 1934. So I tried to read this book, and it was impossible. Impossible. After 50 pages, because it was written in another language, I could not understand anything. And I was very ashamed to see Cartan again and ask him that I cannot understand it. So I went to see another mathematician, Xu, who said, oh, in order to understand variational calculus, you should study algebraic topology first. And what was very important, the year after, in '64, Cartan and Schwarz were running a seminar about the Atiyah-Singer index theorem. And I attended this seminar, and this was my first encounter with K-theory. And I got interested in this theorem, which is very beautiful. And I tried to understand what is a cohomology theory, what is an index, how do you prove the index theorem. So it was a very, very important year for me. And after this seminar, I tried to understand better what was Bott periodicity and so on. I started to write some notes, which I showed to Cartan and Grothendieck. And Cartan told me, after an encounter with him, oh, that's a good thesis. And Grothendieck helped me to write correctly mathematics also. I mean, so the fact that I was working with Cartan and Grothendieck was very helpful for me. And then I got out of my discouragement. And then I got encouraged to do research, yes.
So from my generation, I guess, Grothendieck is this mysterious figure who disappeared. So I was always very curious about him. Could you tell?
No. So Grothendieck, I mean, the picture you have of him is wrong. I mean, he was not, how do you say, priest, if you want. He was very kind with all the students he was working with. See, he looked like an ordinary man, but with a genius which is impossible to grasp when you are very young. I was 23, 24. So I was, at that time, I could not understand what was going on. He was not at all arrogant. He was very friendly with me. And this was very, very important for me. See, because many French mathematicians are arrogant. See, I don't want to give names, but but many of them. And this is terrible for a young student to try to work with an arrogant mathematician. But Grothendieck was not arrogant. He was very friendly, and he helped me. He helped a lot of people, not just me, but all his students, Ilusi, Verdier, de Mazur. I mean, all these students were very friendly with Grothendieck. Yes. So it was a good atmosphere. Yes.
Were you surprised when he left mathematics?
Oh yes, I was. How do you say? I was very sad, in fact, because Grothendieck was somehow very important for many mathematicians in France. And in fact, I tried to follow him. He created this movement, survival. So I went to his meetings. I went to his house and trying to understand what he was doing. But at a certain point, he was leaving the world. You see, he was too naive. You see, let me tell you a story. I mean, he was too naive in some sense, you see, for real life. When I started my thesis, for example, I wrote some notes of seminar, which I call Foundations of K-theory, which is a very, very pretentious. And Grothendieck told me, well, you are doing a good job. Maybe you can ask Atiyah to write a book with you. So I was a little bit surprised, but I said, well, if Grothendieck is asking me, I should tell this to Atiyah. So when I visited Atiyah in '65, I told him, well, Grothendieck is suggesting me to write a book with you. And well, I think Atiyah was shocked because I was very young. He was going to have the Fields Medal, and he looked at me like a pretentious. I mean, what is this young guy asking to write a book with him? He has just finished his thesis, so what does that mean? So Grothendieck was not realizing that there was a distance, a big distance between Atiyah and me. See, I was just beginner in mathematics, and Atiyah was already a very established mathematician. So he was very naive. See, he was very generous, but also very naive. And I think his ideas about survival and what he did after mathematics were also very naive. He was thinking that all people will follow him. He was thinking that life was like mathematics. He can solve mathematics, and then he can solve life problems as well, you see. But life problems are much more difficult than mathematical problems, as you know.
Wow. I've never heard of such perspective. Thank you for telling it.
Yeah.
Could you say some things that you've learned about mathematics or its philosophy over the years, maybe how your vision changed?
First of all, when you are young, you are a little bit pretentious. You think that you have discovered a lot of things, and then it takes time to realize that you are making some good progress, but you are not of the level of field medal or something like this. So you have to be modest in some sense. When you are young, you are not modest enough, but that's maybe a defect of yours. So over time, I don't know, it's difficult to say. For example, if you ask me what are the best theorem I have proved in my life, probably my answer will be different from me and from other people, you see. For example, I think my best theorem was about hermitian case theory after years, my fundamental theorem hermitian case theory, which is now, I think, used by many people, see. So mathematics are not the same now and it was 20 or 30 years ago. And it's very difficult to judge your work. And I think Atiyah, as a good judgment, he said, well, you know, Atiyah said, the theorems people remember are the easy ones, not the most difficult. For example, maybe I'll tell you a story about something I found. It was very, very trivial, which is a pseudo-Abelian completion of a category. See, it's called Karoubi envelope, something like this. This was just a lemma in my thesis, okay? And it was very important, in fact, because later in the theory of motifs, and Grothendieck used it, for example, see? So it's a trivial notion like the Kronecker symbol, but it's like this, you see. When I said I said to Bellinson, that's ridiculous because it's a trivial notion. Bellinson, well, it's trivial, but it's important. See? So something trivial may be important. You see, that's so this thing. This implies that you should be modest because you think that your difficult theorem maybe are not the one you remember later on. You see.
So I wanted to ask you about it. So I was curious to ask, how did you feel about the Karoubian envelope culture? And then I did my homework. I found your article about Grothendieck where you write in French. I understood in French that you write a story how you first heard Grothendieck use this word, Karoubian envelope, yes. And how you were surprised.
Yes.
So yes. How did you feel about this name?
Well, I was in Princeton. I was in Princeton in 68, and somebody told me, oh, you know that Grothendieck is introducing the Karoubi envelope. I said, well, what is Karoubi envelope? He used my name without asking my permission. So this was very funny, but I was shocked because it was a trivial notion. I think maybe people will remember only this theorem in my life. You see, that's ridiculous. You see, but what can you say? I mean, I cannot write to Grothendieck or forget my name. It was Grothendieck was very high, and I could not tell him what to do. You see, it was impossible for me. But I don't like this name anyway. Because, no, he likes the Kronecker symbol. You see, I think Kronecker would be very shocked that we remember the Kronecker symbol without knowing all his work on number theory and so on. You see. So
you mentioned that you think your main one of your main works is on hermitian K-theory, and recently there was a huge work by 9 authors redeveloping foundations of hermitian K-theory and proving new results. And I wonder, what was your reaction? How did you feel about such new developments in the subject you spent so much time working on?
Well, I think I was pleased. In fact, it's a very nice theory, and I was really surprised that this theory was so much developed now. In fact, your work also on that. I mean, you recently publish something. Yes, with OYOS, and yes, I've seen it. I'm doing also my homework. So hermitian case theory, I think, is an abstraction, if you want, of both periodicity. See that? No, I think it's an important subject. I'm pleased that people are working on this. Yeah. Yes, including you.
Thank you. I'm wondering, because sometimes I've seen people of the older generation not appreciating or like being unhappy with new approaches to what they have developed. So I wonder how to preserve this point of view where you're happy about new approaches.
Well, I'm not happy, but also I am a little bit, I don't understand these infinitive categories, and I would like to understand better, see? I would like to understand better. In fact, to tell the truth, I'm trying to find another proof with my method. That's a game, if you want. That's a game we play between mathematicians, trying to find other proofs, and it's nice to have many proofs of the same theorem, you see?
Maybe while we're discussing mathematics, and then we should switch to some non-math, because
yes,
a lot of my audience does not know what we're talking about. But I must use this chance. And since you have observed the development of K-theory from its very beginning and have actively participated in it, I can't resist from asking you, so which questions about K-theory you think we should be thinking about?
I think the new generation need to compute better. See, we are very good in writing theories, okay, but we are not good enough to compute. See, and we should compute more, and in relation with other theories like classical homotopy theory. That's I don't know. This is very vague. This is I know that that would be a dream. But you always start with a dream. And mathematics is a dream becoming reality.
That's beautiful. Good. Yeah, computing is hard. But you already mentioned that you had a hard time reading a book in a different language. So one of my subscribers on YouTube asks to ask interviewees a question: why do French mathematicians write in French, whereas the rest of the world writes in English?
Maybe because of there is a national pride. Maybe that's one reason. But if you want my history, I was writing in French until the 90s, but now I'm writing in English, for example. See?
Why did you change?
I changed because one mathematician wrote me a letter saying he could not understand what I was written in French. See? So I said, well, maybe I should write in English. But I was reluctant to write in English because my English was not so good. It's still not good. So if I try, I shall try to have my papers read by some other mathematician who know better English. See? I don't know, to answer really your question. Maybe it's a question of ignorance. Maybe I was not so good in English. See?
I mean, many people in the world struggle with reading French texts in mathematics.
Maybe French is very close to English, in fact, so that's why. But if I was German, for example, I would not write in German because I know it's difficult to read German. For me. For example, I tried to read the book of Hirzebro, New Topological Method in Algebraic Geometry. It was written in German when I started to do my thesis, but I could not read this book. It was too difficult for me. So maybe because I'm not very good at languages. That's Remember that I started my studies in Morocco. In Morocco, I didn't have so good students, so good teachers. See, if you study in Russia or in France, you have good teachers. But in Morocco, my teacher, in fact, I should have said at the beginning that I was interested in mathematics because my professors in mathematics were bad. I want to do things better than them. See?
That's interesting.
Yeah. In general, you do mathematics because you have good teachers, but for me, it was the reverse. In fact, I remember, but it was not in mathematics, when in physics, I got an argument with my physics teacher because he was wrong. And I told her, she was a woman, you are wrong, this is not good. And she got furious and she told me, Karoubi, shut down, don't, ne parlez pas. So I was very shocked. And I went to my math teacher and I told him the story. I told him, well, this teacher is wrong, I'm right. And you know what my teacher told me, my math teacher, Karoubi, you are right, but don't tell it. Well, maybe that's my first lesson of philosophy. I was very proud to be right. I was very proud.
So you learned diplomacy early on, as we see.
No, I was not. I think I was never a diplomat, you see. Even when I was chairman of my department, I was not very diplomat. I want to change things, and I got a lot of enemies because I wanted to change things.
What did you want to change?
Well, for example, in Paris 7, we distribute money according to the number of people in a group. And I said, well, we should give money only for people who do research. This was normal, okay? But this was not the right attitude. Okay? So I got a lot of enemies.
But speaking of your there must have been some diplomacy involved because as I've learned, and sorry, I didn't know, that you have founded the European Congress of Mathematics.
Yeah.
And you were its first president. So how does one find courage to create such a giant project which doesn't exist? Well,
maybe because, you know, this is a story which all mathematicians encounter. When you reach the age of 50, you said, well, maybe I should do something else than mathematics, okay? And so I was chairman of my department, and I said, well, maybe it's a good idea to create a European Congress. Maybe it was too ambitious. Surely, yes. Because I lost about 2 or 3 years to prepare it. Okay. And I got a lot of money. I got something like 1 million euros. And I got a lot of money. But I have a lot of enemies also. And the French Mathematical Society was not pleased that I took this initiative, because they want to do it, and because they told me that I was not competent enough to run it, you see. And so they took over, and well, okay, that's a story which can happen to everybody, okay? You know, you have 2 possibilities. Either you fight and people you think are crazy, or you take the things with humor. So I decided to take the things with humor. And
that's actually funny. You mentioned already a few times that you made many enemies, and I had the opposite question. So when we first met, I think it was right before my PhD, and it was on Chuck Weibel's birthday conference.
Yes.
And we had a very warm conversation, which I remembered. So then when I was doing my PhD and at times feeling lonely in Germany, I thought, well, at least somewhere in the universe, I have this imaginary friend, the wise man, Max Karoubi, who may or may not remember.
Oh, you're too kind, yes.
But I wonder, meanwhile, you must have acquired like hundreds of friends on all the conferences. So how does one support such a huge network of connections and friends?
So I have a lot of network of friends who I'm in good relation with them. See? And it's in France, I have not so many French. And all my friends are essentially in America, Switzerland, Argentina, or in Chile also. I went very many times in Chile. And unfortunately, with the pandemic now, it's very difficult to travel. That's very bad. But of course, having exchanges with mathematicians is very important, because you can verify your conjectures. You can have some criticism from outside and so on. So it's very important. Yes, you don't have to work alone. It's a big mistake to work alone, except if you are wise and you find you prove the Fermat-Last theorem, and then you can work 7 years alone and try, because there's a problem. You see, I made a mistake in my life. I thought I've solved also this Fermat-Last theorem. I give a talk on this because I have an idea how to prove it. And my mistake was to give a talk about that. And of course, I could not prove the theorem. It was before Weiss, it was in 1990. And the year after, I gave another talk about some other subject. And Quillen was in the audience, and he told me, "Oh, I'm happy that you're working on something else." because when you work on such huge theorem, people think you are crazy. You see, that's a big mistake. If you prove the Riemann hypothesis, don't tell it. Try to have a complete proof before telling it. You see, otherwise people think you are crazy.
So I was hesitating whether to ask you about that, because I have an impression that some people after their retirement tend to believe that they have proved some results, or I mean, okay, not just Riemann hypothesis, there are more examples. So how to age wisely and somehow still see the scale of yourself after having...
Well, that's a difficult question. See, for example, Atiyah, 2 years ago, before he died, claimed he has proved many theorems. And in fact, he gave a talk in Shanghai about that. And it was a pity because, for example, he was claiming that he can prove that the 6-dimensional sphere has no complex structure, you see. And his proof was very lousy. I mean, I could not understand his proof, and nobody could understand his proof. In fact, his proof was there was no proof. Okay, and I hope I will not be like Atiyah. I hope, but if I say something, just tell me, okay? But nobody has the courage to tell to Atiyah that except Sullivan. Sullivan told to Atiyah he don't know about topology. Okay? I was a little bit shocked, but I think Sullivan was right. Yeah, to tell the truth to Atiyah. Well, you know, age is difficult. I think when, for example, Michel Zisman, which is about 10 years more than me, I met him last week because his wife died. And I asked him what to do in mathematics. Oh, yeah, I stopped mathematics because I cannot prove anything. You see, and well, that's a little bit sad, but that's reality. When you cannot prove anything, you have to stop. The problem is when to stop. You see, and so it's very important to have a connection with other mathematicians who are sincere, because they will tell you that you are not good. You are not good to prove new theorems. Okay, but for the moment, I'm trying to prove new theorems. I'm not sure I can, but I try.
But is it the end of the world for a mathematician if they cannot prove a new theorem? Can't one?
No, because there are other things in the world. For example, I am in my house and I plant some plants. I like to work with my hands. There is a part of my life which I don't tell you. I like to work with my hands. Okay? So I design furniture. I have in this place I had a wood machine where I can create new furniture. And now I have a garden when I can put some vegetables and some fruits and so on. And well, life is not just mathematics. It's very important to understand this. Okay? Because some mathematicians think that, there is a nice story, which I learned when I was doing my thesis. If a bomb explodes in Princeton, only mathematicians will know it. But if a bomb explodes in New York, then the world knew it. You understand? New York is more important than Princeton. So the world is more important than just mathematics. Mathematics is just part of science. For example, what is important now is not mathematics, it's biology. A mathematician, there is a problem of sociability. I like to teach, for example, you see, because I know I'm useful. You see, doing research is somehow a luxury. but I'm happy to do it. But I would like to be a biologist also.
So did you also feel the need to be useful when you were young, and how did you fulfill it?
No, when I was young, I wanted to have a job.
Okay, then when you had a job.
Had a job, I want to be useful. Yes, of course. So I want to have a useful job, not just well, okay, you understand.
But how did you fulfill this need to be useful within mathematics?
But to teach, it's very important to teach here, because it's the fact that you teach is some equilibrium for you. See, it's very important not to be just a researcher, but also to propagate science. Okay, either at a very high level, like in Princeton, but also at undergraduate level. See, because all these people who teach mathematics are going to be scientists in some sense. See, mathematics is very important to science, even for biology. So it's important to teach. That's. I think in France we have obligatory mandatory retirement at 65, 68, and I think that's a mistake. I mean, in America you don't have this obligation. I think this is better. You should be able to teach any time when you have the ability to do it. Yes. Are you teaching yourself?
Oh no, I make YouTube channels when I want to feel useful. No, this semester I'm not teaching. Yes. But next year, hopefully, I'll teach my first lecture course in algebraic geometry.
Well, it's important to teach, because it's important to have a relation with other people. You see, when you teach, you also, even for research, it's important to teach, because you articulate your argument in some sense. You see, it's very important to teach for that.
I would be very happy if people like you would teach much longer than 65, but having experience with Russian university where there is no age of retirement, I can tell you that many people are not aware that they cannot teach anymore.
No, but I put a condition: there should be evaluation by the students. Okay. The students should evaluate the teacher. And the evaluation, for example, when I was teaching in United States in the 80s, I got at the beginning 120 students, and at the end I got only 18, because I was teaching the French way. This was very bad.
What is the French way?
The French way was to definition, theorem, proof, example. Okay, and the American way is the reverse. You start with example, okay, and you give motivation and so on. I mean, you create an environment which is appealing to the students. You see, and I understand this when I was teaching in the United States, and so I changed my way of teaching after that. You see, because it's important. So it's important to be evaluated by the students, because if you are old and you're not able to teach, the students tell, well, it should retire. See, so there should be a condition. No age limit, but evaluation. See, that's my. But when I say that, I make enemies also. See?
I like how you say what you think despite other opinions. That's wonderful. So the way you describe French mathematical society, it does not sound very friendly.
No, I think the French society, math society, was very arrogant, because they were thinking that they were the best in the world and so on. And I did not like at all this atmosphere in the 60s. But this has changed a little bit. Now we are a little bit less arrogant. For example, when the students want to make a thesis, it's very important for the supervisor not to be arrogant, because discourage research. You see, that's a question. You see, so we are less arrogant, but still a little bit arrogant.
Why in France? I mean, I don't meet arrogance among mathematicians outside.
You mean why France?
Yeah.
Oh, well, I don't know. Maybe it's you know, we are the country of the French Revolution. We want to we want to be the best in the world, and so on and so on. In Europe, we want to to tell how Europe should go. I don't know. It's a long tradition coming from the. I think France is a country of Napoleon. You see, Napoleon was arrogant. Napoleon wanted to conquer the world. Okay? So it was just 200 years ago. So we are still living on this heritage in some sense.
I see. Okay, this explains a lot. I thought you were past that phase, but okay.
Well, in fact, it was 100 years ago. If you want, in Europe, France was until the beginning of the 19th century, France has a good reputation, you see, in terms of environment. You see, for example, we succeeded to struggle against Germany in 1918, you see. And but of course, the big mistake was not to create Europe at that time. This was a big mistake in Europe. And well, but we are now far from mathematics. I was good in history, in fact, when I was at the school also. So I like history. Yeah. In fact, my wife is historian. Yeah. And my son likes a lot of history also.
History. So we are living now in this new era of having archive as a place to put articles and get mathematical news every morning. So how was it before archive? Was the effect of distribution of mathematics different?
Yeah. We type our. In fact, there is no Xerox copy neither. So I remember I have a typing machine, and I have a carbon copy, and I sent carbon copy to Grothendieck or to Attia to tell them what I was doing, and there was no email, so there was just your usual mail. That's all. See, so but the mathematicians were not so. The number of mathematicians was not so important. You see, so that was possible, but now it will be impossible because we are thousands of mathematicians. You see, but at that time, in the 60s, we were not so many. You have to realize this. In France, we were not more than 200, 300 people doing research at that time. See?
Really?
No.
Oh my God. That's hard to imagine. Now they're...
For example, Michel Zisman told me, because I was a little bit arrogant also, because when I got my first position in Strasbourg, I told to the math department I wanted to go to Princeton first. And I said to Michel Zisman, maybe I was too arrogant. I could not ask my conditions for that. And Zisman told me, oh, but at that time, there are not so many positions available. So this means that people are trying. There were so many positions and very few mathematicians around. You see, it was a good time to have a job at it. See, now it's much more difficult. Having a job now is very difficult, but at that time it was very easy.
How do you feel about this change? How do you think how mathematics is affected by the fact that now we struggle so much to get jobs?
I think the competition is too hard. I mean, this is you should not do. I mean, mathematics is becoming a profession. Before it was a pleasure, you see. And I don't like mathematics to be such a pressure of publication, for example. See, I don't think it's good. You should not publish under pressure. You should publish under your feelings and what you find, not with the pressure of having a job. You see, I don't think it's good.
So I had another unrelated question. I imagine that you care about the development of math, for example, in Northern Africa, where you come from. So what do you think would be the important initiatives for improving situations there, or how one should build connections of Europe and Northern Africa in terms of math?
Well, I think we should send more people to, in fact, I spent 1 year in Algiers as a military after the war to teach mathematics at university, for example. And we should send people, young people to teach. It's very important. Yeah. Or also experienced people, of course, you see, but in general, experienced people have a job, so they cannot stay a long time. But you can imagine a military service, which will be to help underdeveloped countries, see, for example. Instead of doing war, working for peace, like a Peace Corps in America, for example, you see. So you should send people with their PhD to North Africa or other countries to teach. That will be very important. That's my idea.
Sounds wonderful. I remember I had a dream of going to teach to Africa for a while, and you told me I should learn French.
Yes.
And I tried to learn French, but I didn't learn enough French yet. But maybe later, I hope.
Yeah.
Easier to learn French when you live in France.
Yeah, you can. It's not so difficult to learn French. Nous pouvons commencer à parler français si vous voulez.
Requires motivation then. Let me ask you some pleasant questions. So I was searching yesterday through your webpage in order to get more information, and I got distracted because I found photos of my home city, St. Petersburg, and then I fell into the nostalgic. So if you wouldn't live in Paris, I would ask you to confirm that St. Petersburg is the most beautiful city in the world.
Oh, yes, yes. I love St. Petersburg. Yes, yes. You know, I can tell you a story about St. Petersburg because I was in St. Petersburg in 1961. Yes. And it was under Khrushchev. And in fact, when I was in École Normale, I didn't know at all about politics. And people around me told me that I should become a communist. Yes, this would be the future of the world. And other people nearby told me that I should not become communist. That's not a good idea. And I could not make my mind. So I decided to go to USSR to understand it. See? So I bought a car, and with other friends, we went to Russia just to have an opinion.
And how was it?
And among the students, there were my future wife. So I met my wife because I wanted to understand what was communist. And when I came back, I decided not to become communist. But it was mixed because I had some good feelings in Russia. And people were very friendly, and there was also a good sense of culture. A good. The system was bad, but the people were very nice. Yes, I love Russia. I love Russia. And St. Petersburg, I love St. Petersburg. To come back to your question, and I came back many years later to visit many times. I think I went 3 times to St. Petersburg, and next year it will be the International Congress in St. Petersburg also. So I look forward to be there. Yes, I hope I will meet you there.
Let's hope. Let me think. I didn't plan to ask that, but this actually bothers me a lot. So next year is supposed to be Congress, International Congress of Mathematics in St. Petersburg. And due to our complicated and depressive political situation,
yes,
there have been a lot of conversations around about boycotting ICM, which make me personally very sad because it means that mathematicians in Russia will be even more isolated. They already are. So what is your opinion about boycotting research activities in the countries whose politics is far from?
Well, that's a difficult question. For example, Grothendieck was invited in 1966 in the Moscow Congress, and he did not go there because there were two opponents which were in prison, you see. And I do not understand it at that time, but now I understand it. Yeah. So I don't know. To answer your question, it depends how many people will boycott. If there is a huge movement, I will not go. If there is isolated, I shall go, I guess. I'm not sure yet. It depends. For example, the Navalny situation is very troubled for me. I don't like at all Putin politics, if you want. And by boycotting the Congress maybe is not a good answer, you see. Maybe there are other answers, like going to St. Petersburg and making a meeting against Putin, for example. See? Then maybe I will speak about it. And maybe I will end in jail.
But
it's difficult to answer.
Yeah. I have lived in St. Petersburg for 21 years, and I don't recall meeting anyone who would like Putin. So people who get affected by the boycott are not at all supporters of any injustice happening.
Oh. Well, I will tell you next year.
Are there any things you would like to tell to your younger self about doing mathematics? So something you wish students would know?
Psychology is very important. Psychology. I mean, don't work on a problem more than 2 or 3 hours, and do something else after, and then come back to the problem. And have many problems at the same time. So if you don't solve one problem, you have another one. You have not to be short-minded. I mean, to have, and also speak to other people. Because sometimes you have an argument, but if you speak to other people, then you realize that your argument is wrong because you cannot explain it, you see. So it's very important not to be alone in the research and in the subject. Psychology is very important, yes. Yeah. It's very important, but not necessarily being married can do something else. I am very lucky because all my conjectures were proved. So.
I mean, more misconceptions about doing mathematics, about mathematical research.
Well, misconception is to be too ambitious. If you have to be modest. Don't try to solve big problems. Try to solve small problems at the same time. If you have a big objective, except of course if you have Voevodsky or some people like that. But also to work in collaboration is very important because that's a stimulus to do something else. Yeah. And you share your knowledge also. So.
Mm-hmm. So you've already said about it, but I still wonder which changes in the math world over the years you like and don't like.
Well, I like the fact you share ideas very much. That's good with internet and things like this. I don't like too much the competition. See, I prefer collaboration than competition in some sense. See.
Yeah. And do you have any advice from students from faraway countries if they like math, but how can they become mathematicians?
I think the best is to come to a country where you do mathematics. It's very difficult to do mathematics alone in a country which, for example, I could not imagine myself doing mathematics in Morocco. See, I have to come to Paris to see Cartan, Grothendieck, and other people. Yes. You cannot do mathematics alone. You see, that's a collective world.
But why do you think there is this stereotype that mathematician is this super solitary profession where there is this belief that you do it alone, and then you say one should not do it alone. How does it? Why?
No, the mathematician is alone or in collaboration to create theorem to solve it. Okay? But it's essentially solitary work, you see, because you have to be convinced. Even if you are in collaboration, you have to be convinced with a proof. You see, you are responsible. You see, that's in fact, for example, I wrote a paper with Villamayor a long time ago, and there was a mistake because I was not careful enough to check it. You see, and we tried to. This paper was never published because we withdrew it, okay? But it was too late. So we have to pay for the printer. So we have paid our mistake. And that's a good thing. You pay your mistake.
Let me ask you the last question.
Yes.
What is your wish for young mathematicians?
I wish for young mathematicians, well, to be happy. They should be happy with their mathematics, not to view mathematics as a burden. You see, they should do mathematics with pleasure. Pleasure is very important. Yeah, they should be proud of their do and pleased with their work, especially if the proof is elegant, if they find new things and they change these ideas. That's my wish. Yes, you should do mathematics like a pleasure, not like a burden.